Hello everyone. Alright, this is a supplementary video clips that I want you to take a look. But actually this is the third time of recording. The first time in class, but it was not recorded. And the second time I did that about an hour ago, but somehow because of a technical issue, it was not recorded again. So I'm doing the same thing for 3 times. Hopefully this time it may be okay for you. All right, so what I want to do here, this is the item sets. If you look at the grocery baskets, the basket number 10 has grocery item A, C, and D, and another basket 20 has another items C, D, C, E, and E, and so on and so forth. That type of things is pretty much possible if you look at the tables that I posted. For example, the basket 3 contains the item herring, corned beef, olives, ham, turkey, bourbon, ice creams, and so on and so forth. All right. So for this kind of database, we can apply a priori algorithms. All right. So a priori algorithms. The first thing that we need to do is we scan all the data and count the supports. Support means how many baskets contain the data items A. How many baskets contains data item B. For example, in this case, B item contained in the basket 20, B here, and basket 30, and basket 40, and so on and so forth, right? And also, there is a constraints, minimum supports, which means we want to take a look, we want to, for the consideration, we want to mine the rules which occurs this many times, at least 2 times, all right? So if you look at here, for a single data items, if there is any items does not meet this minimum supports, will be pruned out, will be eliminated. So outcome of this first processing is A, B, C, and E. Each has the frequency 2, 3, 3, 3, like this. And with this, the next step is very, very important. We want to associate A and B, and A and C, and A and E, and so on, B and C, and B and E, and C and E, like this, right? This is another possible associations. So each association, we also need to count. We need to see the frequency. And therefore, if there is any associations which is not supported by the minimum supports, then those associations will be pruned out, will be removed. So after we after removal of such under supported association, so we will have now 4 associations. We keep doing this until we find, for example, this. which means we have B, C, and E all together occurs at least 2 times. All right? This is possible data mining in association rules. What is the application of this? Application in the grocery stores, for example, the inventories. If we have a very low inventories of B and C and E are in reasonable inventory, then we need to make a back order for B. Reason for that is those who purchase C and E also purchase B in this probability. Actually, supports is related with the probability, right? So let's try. Let's try the real example that I posted, right? This is a given table. Next step that you could do is to get this kind of occurrence. All right. So first, I minimize the given tables into smaller sets. So basket number 5 contains herring, corned beef, olives, turkey, and yeah, that's it. Yeah, 4 items. And I encoded each basket in this like tables like this, like zeros and ones. 1 means it is contained, 0 means it's not taken, right? So I count the occurrences, count the ones, and finally I have 6. If you use Excel program, then you can get these numbers very quickly, right? This is a formula. Sum the region of the cells from A5 to A18, right? So from A5 to A18. You can copy this all the way to this, horizontally, so that you can have also the formula. If we have the minimum supports constraints 3, then anything below this will be removed. But in our case, nothing will be removed. So that we need to go to the next step. What is next step? We need to associate A and B together, right? A and B together. And then A and C together. A and C together. And also A and D, A and E, so on and so forth. So I did that already, and this is it, right? I have A and B, A and C, A and D, and E, and all the way to this, F and G. And also I count, for example, A and C. What is the formula? Formula is as follows. If we have an AND connector, so this is AND. If A5 and C5 equals 1, then we enter 1, otherwise 0, right? So we did that. We copy that formula all the way down so that you can see that formula. If A and A18 and C18 both are 1, then we put 1, otherwise 0. So once we have the formula this, we copy vertically all the way down. And finally, we can get the summation. We already have a sum here, so that we copy horizontally as well, right? We do that for all the cases. A and F, then if, open parenthesis, A and B for conjunction, A5 equals 1 and F5 equals 1, then we put 1, otherwise 0. So we did that all the way to all the cases and find out if anything above the minimum supports. So I highlighted that. Any columns here highlighted um, pass that second round of association. So this guy has a 3, 3, 3, 5, and 3, 3, 3. So this association has two item sets. We continue to this. Now we have three item sets, ACD and AFG, for example. Okay, this and that. What happens? We made also those similar formula if and A5, C5, D5, AC and D. I didn't put equal sign, but still okay. If it exists, A5, C5, D5 exists, we put number 1, otherwise it's 0. So we did that and copy all the way down. If this is 1, which means AC and D, AC and D, here C and D occurs both here in this basket, but any below, it's not occurred all together. This guy occurs here together, but not A and C occurs together, but not the case of D, and so on and so forth. So we end up having very low supports, and the other also very low supports. All right. In this case, in this simple example, it stops here because there's no additional, the association is possible. If any of three association with three items meet the requirements, then we don't need to do further because I mean, you can try, but for example, AC and D, then can we put AC and D, E? Of course, it is not, it doesn't, because this is not, this doesn't satisfy any additional association will never satisfy that. AC and D, and including more E, then if we put any of these E case, definitely it will not overcome that failure. So we don't need to do any further. So we could stop here. All right. Then someone may ask, how do you then know what is the idea of that? This is the idea. Okay. Somebody already considered that cases. Suppose we have the associations of these cases, ABC, ABD, ACD, and so on and so forth, with the three item sets. Can we have 4 data item sets? The naive approach is that with this, we can go back to the original table and include all the data items, D, E, F, whatever that might be possible, right? But what they found here is that we don't need to do that. We can do simply within here. We can take a look within the current sets and self-joining. And if this guy doesn't meet the minimum requirements, then even though we include each single data items from the original tables would not meet the requirements. So this is the best case that we could do. All right. So how can you do that? We can take 2, for example, see if there is four item sets that you can generate. A, B, and C, and A, B, and D. We are very fortunate, so that A, B together, common, so we have a C and D. So it's very likely A, B, and A, B, C, and D, right? This is very simple cases, but it works in other cases as well, right? For example, if we have A, B, C, and B, D, E, for example, then with this A, B, C, you can include the D at one time and include E at another time, right? So that A, B, C, and E, and A, B, C, and E, right? A, B, C, and D, and A, B, C, and E. You can generate two cases of association based upon this, all right? This is one improvement, one work improved from the original a priori the algorithm. But there are a lot of improvements since it was first invented in 1993. What I ask you to do, for example, given data sets, all right, because this one has about 1,000 transactions available, actually 1,000, yeah, 1,000 transactions. How can you encode it? How can you get the association rules from this? Okay, think about that, and if you have any good idea, if you need any help, any discussions, you could do that. All right? Have a good night. Bye.